polar form of a complex number. So before we get into the topic, as we all know, the Cartesian form of a complex number. What is the Cartesian form of a complex number? It is nothing but z is equal to x plus iy, where x is the real part and y is the imaginary part. We discussed, no? So this is the Cartesian form of a complex number, and this Cartesian form of a complex number can be represented as p of x comma y. Yeah, so this is the Cartesian form. And now we are going to take the organ plane. So that means real axis and imaginary axis. Okay. So we are taking a complex number, and we are drawing a line from origin to that complex number. Okay, to that complex number, p of x comma y. No, p of x comma y is z. Z lies in the first quadrant, and we draw a line OP. So this is the distance from the origin to the complex number. This red line is the distance from the origin to the complex number. And in the last class, we studied about the geometrical representation of the complex number x and y. So how will you represent geometrically? The real part on the real axis, the imaginary part on the imaginary axis. So you know about it. Okay, now we are going to study how we are going to represent this polar form of a complex number in the organ plane. Okay, so the first is theta. Theta. So theta is nothing but the angle between the real axis and the distance from the origin to the complex number OP. Okay. So what is theta? Theta is the angle between the real axis and the distance from the origin to the complex number. So this is theta. And the next is r. R is nothing but the distance from the origin to the complex number. So the theta is nothing but the angle between the real axis to the distance from origin to the complex number, and r is nothing but the distance. Okay, so these two are the coordinates of the polar form. So now the polar form can be represented as p of r comma theta. Okay, so this is the polar form of a complex number. So the polar form of a complex number can be represented as p of r comma theta. Now we have to calculate what is r and what is theta. Okay, so uh, to find the value of r and theta. Okay, so this is the diagram. No, organ plane. You'll be having a complex number in the first quadrant, and you are having r and theta. So this is the diagram. And we are going to use the Pythagoras theorem for this right angle triangle. So where is that right angle triangle? OAP. Just consider this OAP, and we are going to use that Pythagoras theorem. So what is the Pythagoras theorem? Hypotenuse, the whole square is equal to x square plus y square. So you will have r square is equal to x square plus y square. Okay, and from this we can calculate r. So what is r? R is equal to square root of x square plus y square. So which is nothing but modulus of z. And what is z? Z is equal to x plus iy. And you know the formula, right? Modulus formula. What is the modulus formula? Modulus of x plus iy is equal to what? Square root of x square plus y square. So r can also be written as modulus of z. Okay, modulus of z. So from this, this r can be called as absolute value or modulus of z. So in some problems they may ask find the absolute value of z and find or else find the modulus of z. So in these two cases, what you need to do? You need to find this r. So the formula is square root of x square plus y square. So which is nothing but the real part square plus imaginary part square. Okay. So next is again we are considering this right angle triangle, that is OAP. So we apply tan theta. Now we are in the process of finding the value of theta. Okay, keep it in your mind. So we are going to find the value of theta. So for that I am taking tan theta. Okay, tan theta is equal to opposite side divided by adjacent side. So you would have studied earlier. Okay, so tan theta is equal to opposite side divided by adjacent side. So what is the opposite side? It is nothing but y, and the adjacent side is x. So therefore tan theta is equal to y by x. Okay. Uh, from this we can calculate theta. So theta is equal to what? Tan inverse of y by x. Okay, theta is equal to tan inverse. From this equation we can write tan inverse of y by x, and theta can be called as argument or amplitude of z. Okay, so so they may ask you like this: find the argument or amplitude of z. So in that case, what you need to do? You need to find the theta. What is the formula for theta? Theta is equal to tan inverse of y by x. So we found r and theta in this one. Okay, next, we need to find the value of P of r comma theta. In the previous slide, we saw about r and theta. Now we are going to find P of r comma theta. We are going to calculate. Okay. So again, the same figure. Okay. Real axis and imaginary axis, and the complex number which lies in the first quadrant, and you're having r and theta, and also x and y. Consider the right angle triangle. Again, you're going to consider OAP, the right angle triangle. So we are going to apply cos theta now. So cos theta is equal to what? Adjacent side divided by hypotenuse. So this is the formula for cos theta. Okay, so what is the adjacent side? Adjacent side is x, hypotenuse is r. So from this equation, you can calculate x is equal to r cos theta. Okay, and then we need to find y. So for this, we are taking sine theta. Sine theta is equal to opposite side divided by hypotenuse, and opposite is y, hypotenuse is r. So sine theta is equal to y by r, and you will have y is equal to r sine theta. And now, so consider here the z is equal to x plus iy, so which is the Cartesian form of a complex number. And in this Cartesian form, we are going to substitute this x value and y value here. Okay. So if you substitute, you will have what? Z is equal to r cos theta plus I r sin theta. Instead of y, you are writing r sin theta. And what is common term between these two terms? Which is nothing but r. You can take it outside. So z is equal to r into cos theta plus I sin theta. So this is equal to P of r comma theta. So P of r comma theta means what? Z is equal to r. You can take r outside, r into cos theta plus I sin theta, which is the polar form of the complex number z. Okay. Next. Now we are going to find the principal argument. So we have also another term which is nothing but the principal argument of a complex number. Okay, and the complex number. If you take the complex number may lie in the first quadrant, or in the second quadrant, or in the third quadrant, or in the fourth quadrant. Uh, in all the four quadrants it may lie. Okay, so here now we have principal argument. This argument of a complex number depends on the quadrant in which it lies. Okay, so we have the formula for the argument. What is the formula? Theta is equal to tan inverse of y by x. Okay, so if the complex number lies in the first quadrant, then that is the formula. What is theta is equal to tan inverse y by x. Um, Now, if you take the case for the second quadrant, third quadrant, and fourth quadrant, it may differ. So, for this case, we are finding the principal argument. The special property of the principal argument is it lies between minus pi to pi. This is a very, very important property. Based on this, we are going to find the principal argument. Okay. So the principal argument lies in which range? The range is minus pi to pi. Always you should keep this in your mind. Now, uh, uh, in the first case, Z lies in the first quadrant. Okay, Z lies in the first quadrant. So in this case, there is no change. Alpha. No, we are taking alpha. Alpha is not is also argument. Okay. So what is argument? Argument is nothing but the angle between the real axis and OZ. Okay, OZ angle between these two lines. So in this case, the principal argument theta is called as the principal argument. Okay, so theta is equal to alpha. Okay, so this is the first quadrant. And now, if Z lies in the second quadrant, if Z lies in the second quadrant, the angle between the real axis and this line, no, you will mark it like this. You will mark it like this. Only in the you should consider only in the second quadrant. So if you consider the second quadrant, if you want to mark the angle between the real axis and this line, you will mark it like this. So this is alpha. Now we want to find the principal argument. The principal argument will always start from here to this line. Okay, so the theta is the principal argument. So we want only the principal argument. So the principal argument theta will be equal to what? So if you want to find this angle, how will you find? This whole line is what? Pi. The whole line, the straight line value is pi, and pi minus alpha will give you theta. Therefore, the principal argument theta is equal to pi minus alpha, for which case if the z lies in the second quadrant. Okay. Now, now we are taking the case for the third quadrant. Okay, third quadrant. So if Z lies in the third quadrant, how will you mark alpha? You should consider only the third quadrant. You should consider only the third quadrant, and alpha is nothing but what? The angle between the real axis and this line. So how will you mark alpha? So like this. You will mark alpha like this from real axis to this line. Now we want to find the principal argument. So how will you mark the principal argument? From this real axis, it will go to this line. It will go to this line. So if you consider in this case, what will you get? You will get what? Pi plus alpha. You will get what? Pi plus alpha, and that pi plus alpha will not lie in this range minus pi to pi. Therefore, what we are doing here is we are taking the clockwise direction of theta. And if you consider the first case, this is what? Anti-clockwise theta, anti-clockwise, and here also anti-clockwise. But here in this case, we are taking the principal argument clockwise. Okay, clockwise theta. Only the direction changes. If you just compare the second quadrant and third quadrant, everything is same, and the theta, no, the direction only changes. The direction only changes. Therefore, the principal argument theta is equal to what? Minus of pi minus alpha. Because of the direction, we are having theta is equal to minus pi minus alpha, which is for the third quadrant. You are able to understand. Now the fourth final case. If Z lies in the fourth quadrant, how will you mark alpha here? Only consider the fourth quadrant, and alpha is nothing but the angle between the real axis and this line. So you will mark alpha like this. Can you tell me the principal argument for this part? So which is nothing but what? No, the exactly it is similar to the first quadrant, but the direction alone changes. Therefore, what the principal argument theta is equal to minus alpha. Clear? So this is a very important concept to find the principal argument. So try to listen carefully. And now in the next diagram, what I've done, no, I've just combined all the steps in one figure. Just I've written the formula. So the formula for the first quadrant is what? Theta is equal to alpha. Second quadrant is theta is equal to pi minus alpha. Third quadrant is minus of pi minus alpha. Fourth quadrant is minus alpha. Okay. So I just draw the diagram like this. The real and imaginary axis. I mark the first, second, and fourth quadrant, third and fourth quadrant. The first quadrant, the principal argument is alpha. Second quadrant, principal argument is pi minus alpha. Third quadrant, it is alpha minus pi. What I've done here is I've just multiplied minus with this part, no, with this part. So what you will get alpha minus pi. If you multiply minus with the pi minus alpha, you will get alpha minus pi. Clear? And in the fourth quadrant, the principal argument is minus alpha. Okay, keep this figure into your mind. This is very important. Now we are going to find the principal argument of z is equal to x plus iy, and we have some steps to find the principal argument. Let us see the steps one by one. So what is the first step? In the first step, what you need to do is you need to find the value of alpha. Okay. So what is the alpha? So in the previous before 2 to 3 slides, no, we studied the argument formula, right? Theta is equal to tan inverse of y by x. So the same formula you can apply here. Alpha is equal to tan inverse y by x. This is your first step. You need to find the value of alpha. And the next thing is you need to identify the quadrant. Identify the quadrant in which the complex number, no, the given complex number lies. So you need to identify the quadrant. Okay. And then the third one is write the principal argument as per the above diagram. Okay. So if it lies in the second quadrant, you should apply this formula. If it lies in the third quadrant, you should apply this formula. So apply all this formula and you will get the principal argument. What is the first step? You need to find the alpha in the first step. Second one is you need to identify the quadrant, and third one is you need to apply this diagram to find the principal argument. So this is all about polar form of the complex number and the principal argument. And in the next class, we will do the problems. Okay, so when you do the problems, you will get to know about this concept in a clear